So thank you, Dominic. Now, hi everyone. My name is Julia Wambui. I'm also an MSP from Kenya. I study in the Kimathi University of Technology. I'm in my third year doing IT. And like most of you on this call, I'm also interested in learning IoT, and that is actually why I'm here today to learn from my fellow students and to hear what everyone has to say about IoT. So I hope to have an interactive session with everyone here. So if you have any question, just feel free to ask. You can ask maybe during the breaks or at the end during the Q&A session. So yeah, thank you. That's all from me. I now hand over to Dennis or Steven. Yeah, the first speaker. Thank you.
Okay, thank you, Julia. So let me share my presentation because we don't have much time. So I was to speak about what IoT is and how it works. So to get started, what is IoT? So IoT basically is a network of different devices which interact through a network by collecting data and exchanging the data, storing it via the cloud, and maybe visualizing it through user interfaces. So, but basically, IoT is an abbreviation for Internet of Things, and it connects different devices together which can communicate without the need of human interaction. So how does it work? So IoT basically isn't a single novel technology. It depends on different capabilities that work together, maybe to have an output or the final product. So I'll be speaking about the capabilities shortly. They are in the next slide, yes. So the different capabilities that IoT has, it has communication and cooperation, which basically one of the examples can be a fridge which is fitted with Wi-Fi connectivity can be able to send you a message whenever you are shopping somewhere, telling you that you have to buy milk. There isn't milk in the fridge. So there are some different sensors or maybe cameras in the fridge which can basically collect that data, then again send it to you via a network. The next is identification. One of the first identification technologies were radio frequency identifications, which uses electromagnetic fields to identify and track tags attached to objects. The other capability is sensing. So sensing basically, we can have different devices which can be able to sense, like let's say motion. Sorry. So motion sensors are one of the devices that can be used in sensing, then again sending that data to somewhere needed. The other capability is actuation. So actuation basically means turning an electrical signal into physical action. A motor basically or an electric pump are examples of actuators. So the next capability is embedded information processing, whereby a device or something like an Arduino kit can be able to process different information, which it collects data from the sensors, then again process it, then sends it through a gateway to somewhere where it's needed. The next, it's localization, which is defined by deploying a network of sensors to collect and transmit data in order to determine target locations. The last one are user interfaces. The user interfaces enables users to view and understand data captured by IoT sensors. I hope we are good up to that point.
Excuse me, Stephen, just a moment.
Okay.
Your presentation.
It seems like as you are talking, you are not moving your slides, so we are only stuck at the first slide. Yeah.
Sorry, I didn't know that. Let me just check. What about now? Is it okay?
Yes, it's okay.
Okay. So you didn't get to see these slides here.
Yes.
Okay, sorry. So this was the slide which was explaining what IoT is. The next one was talking about how it works and the different capabilities that work together. Here they are. You can see them.
Mm-hmm.
So here's an image which basically shows the processes that takes place. You can see?
We can see it.
We can see
Okay.
You can see, keep up.
Okay, here is an IoT device sensor which collects data from the environment, then again sends the data through a gateway to a data store. It could be cloud or maybe a local storage database. Then again, after that, that data is then processed and the insights taken, they are displayed to the user interface. Here. So this slide explains more about what I was speaking in the previous slide. So here you have different sensors and actuators which collect the data, then again send it through a connection gateway to the cloud. Then IoT isn't a single way technology whereby only sensors can be able to send the data. You can also use smartphones to control the sensors through the gateway. You control these sensors, these gateways, these sensors and actuators. Whenever you want to maybe open a valve or maybe turn on the lights in a greenhouse, as you can see here. So this is an IoT working scenario. So you all have ever heard about Google traffic. How does it get that data? So basically it uses different phones which have location access. Then again analyzes that data since the phones basically sends a small amount of data to the cloud. So it analyzes, then again by getting the speed, you can be able to know that at this point there's so much traffic. At this point it's a bit open. So that's how the devices work via mobile phones. Thank you. So I'm through with my slides. They weren't that long because there are very many people who are talking. Okay, thank you. I hand over to Julia.
Okay, so thank you so much, Stephen, for that presentation. Now I'm going to invite Clinton. Clinton is the next speaker. As you've heard, Josh is in another call, and he was to speak something about how the introduction to IoT. So we're going to have Clinton speak next. Clinton, can you hear me?
Yes, I can hear you, Julia.
Okay, so
hi everyone.
proceed on.
Okay, hi everyone.
Good.
So my name is Clinton.
Hello.
Hello.
Hello, we can hear you.
We can hear you. Okay, so my name is Clinton.
Yes.
I'm a student at the Kimathi University of Technology, a member of the Microsoft Student Partners Club. And today I'll be speaking about applications of IoT. So basically, IoT to me and to the where it has reached now, it's almost the internet of everything. And just to start, I'm going to start with smart homes. Think of a smart home. Actually, smart homes is the highest IoT application currently in the world. And think of it as light control using your mobile phone, curtain control if you want to do curtains at a specific time without you necessarily not being there. Smart appliances, think of things like washing machines, connected washing machines. It also involves things like air control. You want to monitor the quality of air that you're breathing. As you know, most of the times in this world, due to industrialization, there's a lot of air pollution. So you can also control, you may want to know the quality of air that you're breathing. Another application in smart homes is things like security cameras, like the Google Nest, whereby these cameras act as alarm doors, whereby when a person comes, it's not a must to go to the gate to open for the person the gate. You can have a camera there that captures the person's face, and you, where you are, maybe in your house, you have access to control whether a person will enter or not. So I'm going to go to the next application, which is connected healthcare. It's another big application of IoT in the current world. Basically, it usually involves wireless communication systems of things like mobile application and even smart devices that are embedded on bodies of patients to provide services such as diagnosis of diseases, monitoring and tracking, and even if you want to have access to vital statistics and medical information of the person. Maybe most of you have heard of the Apple smartwatch that has the capability of reading the pulses of your heart through your wrist and sending them to maybe this information most of the time usually shared to your personal doctor, who will be having control, and in case something goes bad, he'll maybe know what to do next. Other application of IoT in healthcare include things like maybe headsets. Nowadays they're usually headsets that can measure brainwaves of people once you just wear them. Also for most diabetic people, they usually monitor their glucose level by an embedded device on their body. We usually think of it as the internet, connecting your body to the internet so that you get vital information from your body and share them maybe to your personal doctor, who will be having access to that. Also, think of things like surgical robotic instruments or embedded medical equipment that have sensors in them that can be used during surgery. So when you go to the next slide, we are going to talk about precision agriculture. Think of precision agriculture as something that whereby if it's moisture or if it's humidity in your soil, you just want to have just enough, just the right amount of humidity or soil moisture in your soil, not excess and not too little. Other application other than measuring and monitoring things like moisture and humidity in your soil, you can also, there are applications such as drones, surveillance drones that usually embedded with cameras that can take images of the farm and maybe take photos. Maybe there is a specific disease that is cutting across a certain part of the farm. So by taking the images, you can collect the images through IoT and later analyze them by using artificial intelligence to know whether maybe there's a certain disease that is affecting the whole area. Let's go to the next application, which are the self-driven cars. Most of you have heard of the Tesla. It's currently among the biggest sellers of vehicles in the US. They're usually electric vehicles that can also drive autonomously. But for now, the government and the world have not yet considered this scenario, but they're still working on it. But if you look at a country like US, if you have a Tesla, you're not allowed to make your car just go on autonomous mode all the time. So they usually have something called the autopilot, whereby the driver has the ability to choose whether he wants to drive the car or wants the car to drive on itself. How these cars usually work is that they are usually embedded with sensors, such as distance sensors and cameras, 360 degrees cameras that scan all around the car and check for anything that need to be considered before making the next step. So maybe if there is a person in front, the car can know that there's a person in front and maybe make a brakes on its own. And also just by using the camera and also things like temperature, it usually reads also the temperature of the environment so that the battery of the car also performs in an efficient way. So in the next application of the Internet of Things, we're going to talk about the smart cities. The smart cities is an extension of the smart homes, connected cars, and all the connected healthcare systems that use IoT. For the city right now that have taken the forefront in smart city implementation is Barcelona, whereby in this, if you look carefully at this city, you'll find that everything in this place usually just automated. The city usually just collect data at different data points, be it the vehicles, be it the hospitals, be it the traffic management, efficient water distribution, waste management, environmental monitoring, and urban security. And if you come here in Kenya, you will find that, for example, in a city like Nairobi, at least we are trying to implement some bit of smart cities, whereby you'll find that within the CBD, there are some cameras embedded on the places. So these cameras, what they usually do is that they usually collect images of cars passing through. But I wonder whether at the end of the day, these images that have been collected are usually analyzed to find important insights that can help improve traffic in the city. But at least we are somewhere. Okay, I guess I've finished my part, and thank you.
Okay, welcome.
So, thank you. Okay, just proceed on. Okay, so thank you so much, Clinton, for that session. And in case you have any questions, feel free to type them in at the chat area. We'll respond to them after. So now I'm going to invite Hatsi. If you're on the call, kindly present your session. Hatsi. Is Hatsi on the call?
Is he around?
Hello guys, are you talking about me? I'm
Yes,
Ganesh.
it's your turn. It's your turn.
Okay. Okay, so I will start sharing screen right now. Okay.
Okay.
So are you guys able to see whatever I'm sharing?
Yes, yes.
Yes, we can see.
Yeah.
So the topic which I will be sharing with you guys and trying to present here is IoT security. And though I haven't worked professionally in it, but I have made a few projects and I'm very passionate about being in IoT and being an IoT developer. So the main thing I will be sharing is why is it necessary? Because IoT security and IoT apps are very, in the growing sense, and what are the risks if you have with them. So a little bit about myself. My name is Ganesh Tiwari. I'm doing masters in computer science from University of Mumbai, India. I'm a Microsoft student partner. I like to learn Python and Kotlin, and I like listening to rap music, if that matters. After this, here begins our first slide, and this is a quote I like to keep in my mind whenever I'm developing something. A good programmer is someone who looks both ways before crossing a one-way street. So we are the ones who know the real threat. We develop apps and we know how a hacker can hack stuff and take benefits of the little most uh, things which we do wrong in our applications, and then we can exploit it. Moving on to the next session, next slide. Why is IoT insecure? So if you think about it, why is IoT insecure? So I am presenting a few things which I think are the reasons why IoT is insecure. So the first thing I think is there is a difference of ideology in the people who are developing. Oh, why did my slide change? Is someone okay? Is it currently on a why is IoT insecure? Hello.
No, it's not.
No.
Oh, someone is doing something or what? I don't know.
Yes, someone is
Okay.
taking control maybe.
Yeah.
Yeah, so why is this happening? I was trying to do something.
Share it once again.
Okay, wait, I'll do it once again. Mm,
I think what's happening it's on auto slide.
So anyone can take control, yeah.
I think it's on auto slide.
okay, so the one of the main thing which I think is hindering in IoT security is the difference of thinking between managers and engineers. Managers have a typical thinking which where they only think about the projects. Uh, they want your app to do something or your project to do something. They have an end goal. They don't think about what all things are required in the project, or what is the difficulties in using a IoT device versus a normal device. Here I have a image which should describe You know, if you can take a screenshot of it, it is a like meme which I like to do it. Uh, Engineers might not be interested in, you know, focusing on the risk. Sometimes they like to tinker around and play only with the functionality. They only want to be the fun part. They don't want to be in the security area. That is reason. And the second thing which I would share is transport is not the only problem in IoT, because whenever we think like a programmer or a developer is developing a app for, you know, IoT purpose, the first thing that he would think is like, yo, IoT development is simple. The only thing which I need to worry about is, you know, take care of how it's moving and mobile. But thinking in a security type of view, it is not the only problem. So there are many problems that you might face, like uh, uh, a product which you have developed might face uh, a physical damage. The product can be, you know, taken into control by a enemy or Oscar, which we say is like a hacker or something, which likes to take care of the vulnerabilities and you know, take benefits of it. Okay, so what are the problems in IoT here? So the first thing which I want to share is like, this is a GIF. This is not loading. I don't know why. So this is a GIF which shows robots are dancing and you know, doing different stuff which they are not supposed to do. And then here I have the video. It's like, you can see robots malfunction every time. So, you know, if you are building a bot, it is not, you know, uh, definite, like it would fail because some of your problems. It might be like the robot is not in the correct atmosphere, or the robot is not in a correct phase. It will fall along himself only. uh, Third thing which I would share, if the slides allows. Okay, solutions in the older fields do not work well with IoT. So what do I mean with solutions in older field do not work with IoT? So think about it like this way. So suppose, you know, what we developers like to do is reuse the code. You know, we reuse our previous experiences and like to put it in the next application we are building. But this is not the case in IoT. The communication patterns designed for web applications or, you know, mobile applications are not the same for IoT. So if you you know, make a REST application and you use it in your mobile app or web project, that is not basically used in IoT fields. You know, you have Arduino or some other platforms which do not work well with REST APIs. You need to use something more lightweight and, you know, something which would take less power. So you need to take care of new fields, and you need to think in a new way. Okay, uh, reusing solutions is different. So yes, this is similar to what I had said in the last way and last slide. You know, when you are building a solution on an old architecture, you are working with a system which is either in a secured way. So take a web application. Web application is built on server, which is well in a firewall system. You know, if you use Azure or Google GCP, they are all in a secure and gated community. And the client side is also maintained by a person who is using it, and it is also pretty well secured. Many people have, you know, antiviruses installed on their PC. But when you talk about IoT devices are not always kept in a secure place. You know, they tend to wander around. They are meant to be mobile, and, you know, They are not just meant to be deployed in laboratory and you can keep it for years to come. They need to talk with each other, and they need to talk with other machines on the internet. So this is the thing which is not possible after we have discussed like what are the problems and why IoT application is are more vulnerable than normal applications. I would take a few modes of attacks which are normal in normal worlds and also in the IoT world. So the first main thing is denial of service. Then what is I will talk about these in the future in the further slides, but let's just count them. First is denial of service. Second is guessing credentials, creds. By creds I mean credentials. And the third is getting access to credentials. So, and the fourth is man in the middle attack. And the fifth is a sniffing of a network communication. Sixth is port scanning and web crawling. Seventh is search features and wildcards. Eighth is breaking cipher. So I will explain about them in a quick way, and then I have a few topics which I have dedicated a few slides on, and then I will explain them. So the first thing, denial of service, is basically you know putting a lot of requests to a device and hoping that the resources of the server or the device, whichever it is attacked, the resources fell low and the device stops responding. So it is basically an attack where you want the server to go down and stop responding to your requests. The second is guessing credentials. So in every application or a platform, there are certain login and log out features where you can access features, and they all require something like a username, password. These can be easily hacked. People are the most vulnerable things in current you know application development atmosphere. It is difficult to hack an organization, but you can hack a person in 1 or 2 days if you get close to it. And the third part is getting access to the credentials. Sometimes you can't guess credentials, but they might be lying around in someone's phone. So if you get access to someone's phone and the person likes to keep it in a note or something, you will get access to that credential. Or if a person likes to keep it in a diary or something, you would get the access to it. This is a very you know old old school kind of a attack, but yeah, it's pretty good way of attack. The fourth one is man in the middle attack. So what are man in the middle attacks? Man in the middle attacks are something in which if you are trying to access a resource directly. So say that I am accessing my Facebook account, but some hacker he would be in the middle of my and Facebook's connection. He would be sniffing whatever I am, using on my Facebook account, whatever photos I'm posting on it. That and then there is a sniffing network communication. So suppose the hacker or anyone who is, trying to get access to your things, mm, somehow, some way he gets in your network. What he can do is he can there are some tools like Wireshark and NetPcap. They can sniff through the whole network. They will monitor every request that is going on and out. And this is similar to something like man in the middle, but it is not that much similar, because this is not a direct getting in between two people, but it is rather you know sniffing through the whole network and trying to find something critical information in order to gain access. And the sixth one is port scanning and web crawling. So if you have few servers or devices, deployed around on internet. So the first thing, if you look into a hacker's book, the first thing that would be a reconnaissance, and then finding weakness of a server or a device. So how do you do that? You basically scan through all of the ports and see which ports are open or accessible, and then what they say is, if the port is accessible or open, which applications are deployed on it. If the application which is deployed on it is a vulnerable application, they can easily uh, take advantage of that vulnerability. All these vulnerabilities are, most of them are openly accessible. Someone out there somewhere is writing some patch for it, but you never know when your application is vulnerable. And the 7 thing is search features and wildcards. Search features are like, you can search on Google for some vulnerability. So if you keep your whole domain accessible to Google, and you don't have a private path, and everything is visible to Google, sometimes there are some codes like which you can just type into Google and get some critical details about some servers. Some people like to store their credentials in an Excel format and then just deploy it onto the server. They don't care to think like this whole thing is scanned by Google and they are making it available on the search engine. So a hacker might take benefit of that opportunity and search Google for those credentials, and Google will just show them, because and they would be able to access this because you have not laid any security on it, and it is open for everyone to view. And the last one, and the most thing which is very rarely done nowadays, because ciphers are very strong, breaking cipher. So this is like, you have a cipher. Basically, if you don't know what a cipher is, uh, take a password, you apply some mathematical calculations to it, you apply in a salt into it. Salt is something, a random part which you can add into it. Apply some mathematical calculation to it, and then the same password will become a random character, an unrecognizable character. That thing is called cipher. So as the cryptography technology evolved, it is very less likely for a person to break cipher, but it happens. Now I have a few slides that I would like to go on deeply in. Denial of service. As I have told, denial of service is when someone tries to overload your server by giving us countless requests. So denial of services attacks are two types. First is a device attacks on a server, and the second is DDoS. DDoS is distributed denial of service. In it, there are multiple, you know, PCs which are attacking the same server. So this is where IoT is critical, because there are so many mobile internet connectable devices available because of IoT. If a hacker or a person trying to do some bad stuff get gets a hand on those devices, they can lay mayhem with this benefit. Uh, and actually in today's days, Akamai researchers have filed in a research where they say like most like 21% of the DDoS attacks that are currently happening in the world are done through use of IoT, Internet of Thing devices, because they are so vulnerable and open out there in the real world. I have read about an article where it says like a hacker used the CCTV cameras to do a denial of service attack on the server which was recording all of the stuff. So what can you do for this? You can basically, just like the attackers have decentralized the attacking system. You can same with it. The server or wherever you are storing the data, you can make it decentralized and make sure that a server or a single instance doesn't carry that much of our information. So it is very less likely for a hacker attack on it. Next slide is guessing the credentials. This is like, are you guys able to see this GIF? I would like to know. Hello.
No, we can't see the GIF.
We can view it, however, it's not playing.
Yeah, so I had made this funny GIF. I researched a long time for this, but this is not working. So this is a GIF of Pooh trying to think. And after this is a very famous GIF that you guys might know. And
Wow.
then yes, and then this is the real way how a hacker tries to guess the credentials. He gets into the computer and then tries multiple ways, and then he gets the credentials. And then there is getting access to the credentials. I talked about this. This video is a monkey stealing a car's some stuff, and he's running away, and the owner of the car is running behind him. So I will share this slides with you, and you guys can enjoy it if you want to. Getting access to the credentials, as I earlier said, is if a guy or a person likes to store it, his credentials inside some uh, a diary or a book, he can easily take that diary or book and steal that stuff. How can you prevent on it? Use long and uncommon passwords. Make sure that every device has a unique password. Never store your credentials centrally, or if you plan to keep storing it somewhere, make sure that it is encrypted and not any common encryption. You can use some high-tech stuff like SHA-1 or SHA, or there are many stuff around there. And then it comes as like man in the middle attack. So this is a very funny GIF too, which I wanted to show you guys, but I guess this is not working. And then how do man in the middle attacks work? So I have made a visualization, if you guys can view it. Suppose there is a person named John and he likes to message Juliet. So they actually talk a lot and they have a direct connection in between of them. But someday, due to a network problem, their network connection broke. Okay, they were again trying to reconnect between each other, but they were not able to do because the server was down, and because some hacker or a evil person took control of the server. And then what he did was placed in a code of himself, which was acting in between, and yeah, let's name this person or the hacker as Oscar. And now he placed a code which is getting in between of John and Juliet, and whatever messages they are sending, they are going through. It's like John sends the message, but it reads Oscar first, and then Juliet, and whatever Juliet sends get first to Oscar and then to John. Now these man in the middle attacks can be of two type, like active and passive. Whatever active means is when this Oscar is actively changing the messages which are getting from here to there. And the passive kind of attack is when he doesn't do anything, he's just reading all the messages. He's like scanning through all of them and not taking control and changing any of the text. Now, and moving on to the next slides, how can you make, okay, so I had mentioned 5 more attacks, but due to less amounts of time we have here, I would be explaining only the top 3 topics and moving on to how you can make your IoT devices more secure. And here also I would be only talking about only a few topics, and then I will end the session. So how can you make your devices more secure? Using virtual private networks, X509 certificates and encryption, authentication of identities, usernames and passwords, using message brokers and provisioning servers. So I will explain all of them in a few words, and then I will explain a few of them in deep sense if I can. So what is virtual private networks? Virtual private networks are like, saying that you and few devices, you are in a private network, and the rest of the internet is beyond that network. So these 5 PCs which have been selected or are in a virtual private network, they can communicate with each other directly. So there is nothing stopping them, to connect with each other. But when they try to access something else, like if a server who is in VPN1 tries to access a website like Google, he would not be able to access it if the virtual private network is defined in that way. That is a way of trying to keep your IoT devices centralized and making sure that they are in a private network and do not interact with the devices which are outside of that network. And the second thing is using certificates and encryption. So whenever your device is trying to access another device, you can use something known as certificates, which is made by an authority which is legal and known to be trusted. So if a person who is trusted makes a certificate for all the non-trusted persons, so whenever the non-trusted person is trying to access some resources, he will show that certificate, like I am from a certified person. So if that device has that certificate, then he is bound and legal to accept all the services. That is some kind of security. And then just like that certificate, we can also make some authentications. Like every time a device wants to access something, we can make an authentication layer which will always check whether the device is eligible to access the resources or not. And the fourth one is using usernames and passwords everywhere possible. You can't leave a link behind which is unchecked, or a resource which is unchecked and can be accessed by anyhow, because these are always vulnerables. You can use message brokers and provisioning servers. Now I will go deep into virtual private networks. Yeah, I think I actually went deep when I was describing them. So a method that is used to often protect unsecured server solutions on the internet is making them to behave like they are in a virtual private network. So if they are in a virtual private networks, they will only allow the persons who are in their virtual private networks to access that resource, even though they both are on the internet and can access internet, but they will not be allowed to access resources from outer internet, if that makes sense. Encryptions, I have made I have found this image on ResearchGate, and the normal X509 certificates are made for servers, but in the IoT devices it is a little bit different, and the way of making it is described in this image. I will be sharing this PPT so you can have a deep look at it, and it is nothing but describing the whole architecture of the person who is receiving the certificate and a few details about the loyal or well-known certificate giver, so that we can authenticate with the certificate giver that if you have given this resource, then it is legal. That's sort of thing. And then putting in usernames and passwords. So this was also a funny GIF where it was scanning his eyes. And how can usernames and passwords be done? So everyone logging in or accessing a resource should always authenticate himself or herself. No resources should be unchecked. Usernames and passwords is a good way to give someone access to a resource. There are also some practices where like PSKs. So if you have made a resource on AWS or Azure, they when you are launching or spinning a VM, they give you two ways of accessing that VM. So first way is through usernames and passwords. Second one is pre-shared keys. So pre-shared keys are generated by them, and when logging in through those pre-shared keys, you don't need to provide usernames and passwords. You can just provide in that key, and it will automatically authenticate yourself. Uh, Moving on to the next slide. I guess that brings an end to my session. And if you have come too far till the end and have learned something from it, I am very thankful for you guys to calling me here. And I'm happy to end this session. Thank you very much.
Thank you.
Hello, thank you, Ganesh, for your talk. Our
So,
next guest is Dan.
so I am sorry if this content ended up abruptly because I didn't knew what would be the length of this presentation, and I had a lot of content prepared, and so I had to fix it in a time, and I hope you all guys enjoyed it, and bye.
Okay, bye. Our next guest is Mwasela. Can you hear me?
Yeah, I'm here. I can hear you.
Okay, it's your turn now.
Okay, so let me just share my slides. Just a second. Can everyone see this?
Yes.
Yes,
You
we
can.
can.
Okay, yeah. So let me just begin. And I'd introduced myself in the beginning of the session, but not everyone was here. So I'm gonna do that again. My name is Mwasela Dennis. I have a degree in electronics and computer engineering from JQuat, and currently I'm the innovations lead at Microdam Technology. Okay, yeah. So today I'm going to be talking about IoT communication technologies. And I hope you're going to enjoy the session. So without much further ado, let's begin. Just a minute. Are the slides moving on your end?
Yes, they are.
Okay, yeah. So I will start by asking why we will need communication in IoT. So first of all, it goes back to the very basic definition of IoT, which is simply networking of things, giving them the ability to talk to each other, and in that way, they can be able to send and receive data from one IoT device to another. So it can also be instruction. It doesn't have to be data. As Steven was presenting, he mentioned he could send instruction from a remote mobile phone to a remote sensor or an actuator, like controlling lights. That's an instruction you're sending. But it is in form of data. So whether it's an instruction or not, that will be for the other device that's receiving on the other end to know what it will do with that information that it's receiving. So moving on types of communication in IoT. So communication in IoT, I would have said from the beginning that it's quite jumbled up. You cannot approach it from one particular angle. It can be, people normally have a hard time differentiating between protocols and the actual hardware used in communication. For example, in this case, I'm going to use two broad areas of classification to classify communication in IoT, and that is MCU to sensor, microcontroller to sensor, which you can call intra-board communication, and then finally we have microcontroller to cloud. So these two types of communication, they might be communication, but they occur at different settings as per se. So I'm going to start with a microcontroller to sensor communication, which mostly facilitates intra-board communication. That is communication between a sensor. It can be a temperature sensor to the microcontroller. It can be an actuator to the microcontroller. So these types of communication are usually low, short range, and they send small bytes of information. You don't have to be uploading a video from a sensor to MCU. That normally doesn't happen, but just instructions and data as per se from sensors. So let me go to the next slide, beginning with sensors to microcontroller. And there are normally three types of major communication technologies. I cannot call them protocols because some of them are hardware based and some of them are software based. So I'll approach them from this angle. So the first one is UART. You might have heard of it or not, but you use it a lot every day in every day-to-day life. So this stands for Universal Asynchronous Receiver and Transmitter. Basically, I'm going to explain more about it in the next slide. So let's just explore the other forms of communication between sensor and the microcontroller. We have I2C, which stands for integrated circuit. And then we finally have the SPI bus. So moving on to describing what UART is, it's simple communication that uses two lines. That's the transmitter and the receiver, usually denoted as TX and RX in most open source communication. And it occurs in serial, obviously. And as I said earlier, in microcontroller to sensor communication is short range and is also low speed. And yeah, so there's nothing much to explain about UART because most of what you use in UART is done in the implementation, and mostly it doesn't require any libraries to work with when you're working with an open source board. That is, you just plug in your RX, that is the receiver pin, to the transmitter pin of the other sensor, and then the transmitter pin of that other sensor is fixed to the receiver pin of the microcontroller unit. So basically TX to RX, RX to RX. It can facilitate communication from any direction, but that is only done at a given time. So it does not support bilateral communication at any given point. That's a shortcoming of it, and we'll see how we overcome it using the other methods of communication between microcontrollers and sensors. So applications of UART, some of the technologies using it is Bluetooth Low Energy. In terms of open source applications, because that's what we all are familiar with. If you've ever worked with a Bluetooth module, an example is the HC051. We also have the HC061. It's an example of a Bluetooth module. It's open source. That means you can use your own code to access the information that is being sent via Bluetooth. Or you can use other people's libraries that have definitions on how to access the registers inside this sensor and obtain information from it that is coming from another Bluetooth device, that is. So another application of UART, we have GSM. The GSM modules, they also use UART, but they have their own So this is where I wanted to explain about protocols and technologies. When it comes to protocols, most of them are simply software based. But when it comes to the hardware technology, for example, we know Bluetooth as a short range communication method for sending small types of data, right? But the underlying technology that is being used by Bluetooth Low Energy is a simple 433 megahertz oscillator. Okay, that's quite advanced. I did engineering, so you have to forgive me for the hard words, but I'll try to be as simple as possible. So I will leave more about Bluetooth energy there because we still have some quite a lot of content to finish up and time is moving. So another application is the GSM, as I've said, and then we have the NFCs. Most of you have used NFCs in your phone. It's actually faster than Bluetooth, and it also gives out short-range communication. And okay, so UART by itself cannot use NFC directly. It has to be modified into a way that it can work using the NFC communication protocol using software. But the kind of hardware that you're using to communicate is simple RF signals, radio frequencies, specifically at 433 megahertz. Yeah, so moving on to the next type of communication between a board and a sensor, I have the I2C communication, which is an improvement of the serial UART, and it can handle. Okay, the best thing about I2C is the fact that it can handle so many inputs and then channel them using one serial output line that is controlled by a serial clock. So in I2C, it's quite advanced than UART because it has a clock. When you look at UART, it doesn't have a clock, meaning the information that comes in is not synchronized, it's just being received. There's no particular way or time that it should have come that you should be actually be looking out for. But as data comes in, you just store it, read it, and forward it to whatever place you want to forward it. But with the I2C, it has two lines, the SCL and the SDA. So the SCL stands for the serial clock, and the SDA is the serial data out. So the serial data out, what it does, it basically it's the one responsible for carrying the actual information in terms of bits from the master to the slave, or from the slave to the master. And then the serial clock, it generates a pulse. So for every pulse of data, okay, the data can be, it's normally represented in binary form. So it can be, for example, you want to send a 3. A 3 in binary, it's 1, 1, right? Yeah, so in this example, what the SDA will do, so these are two numbers that we are sending over the I2C channel. So these two numbers will be represented by a signal, which is a sinusoid, but it's a squared sinusoid. So this signal is coupled with this clock. So if the data that comes in at 1 and the clock was also at 1, and then, for example, when it gets to the receiver end, and then let's say the data that comes in is a 0, and whatever was on the clock is not matching with the data. So that's when you get a cyclic redundancy error, because the information that is leaving from the master to the slave, or from the slave to the master, is not getting there the way it's supposed to be. I2C invokes security measures that prevent the data you are sending from one device to the next from being corrupted on the way, either by, we have things that can corrupt data when it's on transit, especially if it's on transit through wire, like electromagnetic induction. They can distort that information. Yeah, so another The salient characteristic of I2C, as I said earlier, is the fact that it can only be able to communicate with only 2 wires as the output, that is. For example, even if you have a multiple output channel, for example, an LCD, that's the simplest example I can use. It has around 16 pins, 12 pins if I'm not wrong. But to connect them all to the Arduino, the wiring becomes so messy if you're working with open source technology. But if you add an I2C chips, it's basically what I can call an ADC, an analog to digital converter. That's what it basically does. So it converts all the analog signals coming from all the multiple channels and then converts them into one serial block of information and then sends it serially using only those 2 lines that I've mentioned previously, the clock and the data line. So it's also powered by small voltage, 3.3 or 5 volts, though other voltages are acceptable depending on the type of technology you are using. Most companies actually invoke I2C. It's not just used in open source technology. It's used by many companies when they're, okay, you'll not notice this because most of this is done inside the package. Like when you're developing a device, you have a given like the logic unit. You want the logic unit to communicate to the memory unit. You use an I2C line. It's way easier. It's way uses less lines, uses less power, and it's less complicated. It's very easy to implement. So that's why I2C is mostly adapted by many electronic vendors that actually manufacture these devices by themselves. So another piece of information about I2C, as I've said, it's clocked. And this means when something is clocked, it means it occurs at a certain fixed frequencies. And most of the frequencies that these devices operate on, which is sufficient for almost all of them, is between 9,600 and 115,200. That's the baud rate which can operate. It's like the frequency between which it can send information. So this is quite very helpful and very, I can't get a word to actually put it, but it fits the description when you are doing interboard communication inside a device. Yeah, so another characteristic about I2C, probably its uses include accessing displays, as I said when explaining about I2Cs. DACs, these are digital to analog converters. ADCs, I mentioned them, analog to digital converters. We have accessing real-time clocks. That's an I2C can do that. And then it can also be used to access RAMs, as I've said. It's an example I've used. So these are non-volatile RAMs that actually store information about a user. So you can use an I2C bus to get information from this RAM and take it from wherever you want to wherever you want, probably another device within the same, another component within the same device. So the number, okay, so as I've said earlier, in I2C, it can handle many input lines, but then has only 2. So the number of input lines that you can actually put in one single I2C depends on the size of its address register. The address register is responsible for taking in all the addresses that are actually supplying information from each input line. For example, if you have pin D1 to D7, all of them are outputting information. So the address register will make sure that it knows this signal is coming from pin D1, this other signal is coming from pin D2. So depending on the size of the address, how many addresses it can accommodate per given time, then those are the number of input lines that it can support at that given moment. So another thing about I2C is that yeah, it's a downside actually. It does not support bidirectional communication. You can actually use achieve bidirectional communication using I2C, but they cannot work at the same time. You'll have to implement two different hardware implementations for you to have a bilateral communication. So one piece will not actually suffice for that. So that's a bit about I2C. So I'll move on to the next slide, which talks about SPI communication. So, so when it comes to the serial peripheral interface, it's also an improvement of UART. So from UART, the communication types just keeps getting better and better in terms of speed, in terms of the data they can handle, in terms of the number of devices that can be communicated to by one master. So in terms of SPI communication, we have a setting. As you can see on this picture, it chooses a configuration that has a master and a slave. So the SCK is the serial clock. We have the MOSI is the master out, slave in. And then the MISO line is the master in, slave out. So as you can notice, the MOSI is connected to the MOSI and the MISO is connected to the MISO. What does this tell you about SPI communication? So getting back to the last slide, I talked about bidirectional communication and that I2C and UART cannot support that. But SPI communication solves this problem. So as I've said, it's an improvement of UART. It is also clocked using this SCK. It has 3 communication lines. So on this block, you can only see 2, but that doesn't mean that's the end of it. You can add select lines below that will actually enable you to have multiple slaves and multiple masters at a given time. So this will actually enable bilateral communication, and you'll be able, most of the sensors that use this type of communication have worked with NFC. NFC has to use SPI. For example, we have the cards, the 125 kilohertz cards that people usually use to access probably a door, or it can be opening a parking garage, or the same card can be used to store your medical records. And you can go to a medical center, you just put the card, it reads the information, and then if you, after you are done, it updates it to the card, and then you go back home. So 3 communication lines, MISO, MOSI, SDK, and then you also have an extra select line that can be used to select other multiple masters and slaves that might be hardwired to the same communication bus. So advantages of using separate lines for master-slave configuration, as I said, it enables bilateral communication. So MOSI and MOSI can be communicating, and MISO can also be communicating at the same time. So you don't get that with these other forms of primitive communication. So I think that sums up a bit of communication between microcontrollers and sensors. So depending on which type of sensor, when you actually want to move to advanced communication, you will actually have to come up and decide which type of MCU to device communication that you want to use, depending on the nature of the data you are sending, the timings, and everything. So that sums up. And I think I'll be moving on to the next, which includes communication between microcontrollers and the cloud. Yeah, so I'm moving fast because you only have 12 minutes to go. So most of these solutions that offer communication between your ground node and the cloud, they are mostly proprietary, and they will require some sort of infrastructure to access. Most of them are high speed, and yeah, they are more complex to configure with open source solutions than you would with the other types of communication that I've mentioned. And most of them require extra hardware to enable you to communicate, because an Arduino does not have any transmitting capabilities, wireless that is. It only has the TX and the RX lines, it has the MISO, and also the analog. So you'll have to decide some hardware that will actually be able to pick this information from the Arduino, probably from some field sensors, and then convert them into a form that can be easily accessed or transmitted over the internet and into the cloud. So let's explore which technologies these are. So we'll start with MQTT. MQTT is a communication protocol. We also have Sigfox, and then we have LoRa. I was asked to speak about other communication technologies, a microcontroller to cloud, but it will just be a repeat of myself since I'm talking about their functionalities, how they work and everything. LoRa and Sigfox are quite similar, only that LoRa is mostly LoRa has been there for quite a while, since 20, I think it's been around since 2005, if I'm not wrong. But Sigfox came around the other day, and its availability to the whole world is quite limited. But we have vendors trying to change this. For example, in Kenya, for Sigfox, we have this company known as Liquid Telecom. They are the official agents, and they will enable you to access the Sigfox network from Kenya and use it in your projects. So without wasting time, let's talk about MQTT. So it's a protocol. It uses the internet stack, just like all the other online communication protocols. And then it enables you to publish Internet of Things sensor data from your sensors to the cloud. And you have to do this via broker and using a transport layer that is you're actually comfortable with, and your broker supports. So it also has TLS encryption, meaning it's secure communication. You can include a login and a password to a certain cloud service before you actually post information to it. So no one from any other place can just post random information to your cloud infrastructure. It will affect your whatever you'll be doing with that data after that. So another improvement of the MQTT, I cannot call it an improvement, but a property. It can handle any amount of data depending on your internet speed, as long as it is like in your phone. As long as you have bundles, you can be able to browse, right? Yeah, so MQTT uses a transport layer protocol that is similar to that you use on your phone. It can be TCP/IP, it can be UDP. They are all transport layer stacks, but they have to be supported by your broker for you to be able to use them. So the broker is simply a service provider that will be actually receiving this data information using the MQTT library, and then from there you can forward it to any cloud service you want. It can be Azure, it can be Firebase. I've used Firebase before, but linking with Firebase has been so not good. So I would recommend people to use Azure IoT. I have my own account. I have my own nodes that I've launched in Microsoft Azure, and I'm using it without any problem. So that's what I would recommend. And then the rate of communication, of course, depends on the internet speed, and the implementation, as I said, requires extra hardware. Like the Arduino or any other open source board does not have any communication capabilities. You have to add them for yourself. In this case, it will be any internet connection device. It can be a Wi-Fi dongle, but people normally use the Node MCU because it comes in with extra information and it's widely documented, so that any new buys can actually use it without any problems. Apart from that, I don't think there's much to add about this type of communication technology. But if you want to go ahead and explore, you can get yourself a Node MCU go online, download their libraries, and start communication. We have free brokers like ThinkSpeak. ThinkSpeak is a free broker. You don't have to pay. You can link your MQTT-enabled device with ThinkSpeak and be able to upload field data to the cloud with ease. So next on, I'll be talking about the Sigfox technology, which I've mentioned. Sigfox is proprietary and it involves, it operates on a narrow band. What do I mean by on a narrow band? Okay, so when you're using your phone, it normally uses the GSM spectrum, and it's a given range of frequencies that mobile phones actually operate on. So, but then below the GSM spectrum, there's another range of that is normally identified as the narrow band. I don't know how to explain it in layman's terms, but it's basically unused mostly in many countries. It's not assigned to anyone, so it can be used for other types of communication without having to fear about interferences and everything. So in Kenya, as I said, Sigfox is brokered by the main agent is Liquid Telecommunication, and if you want to use Sigfox in your projects, all you have to do is reach them. Liquid Telecommunication. You can buy boards from them. They have boards that are actually enabled to use the Sigfox network. I've used them before. And when they give you this board, it actually comes with a lot of libraries and support information. All you have to do is just work your way on how to pick information from the sensors, and then the libraries that submit information to the Sigfox backend are all available because it's something you have to pay for. And I guess the support from the company that is giving out this capability is quite superior when compared to other free methods of communication or uploading to cloud. So as I said, you'll require a special board with its own antenna that can access the narrowband and be able to communicate with it. So, Sigfox communication has its own limitations, which are actually similar to those of these other narrowband technologies. It can only support, okay, this is a cap kept by the Sigfox team itself. You can only have a maximum of 90 uploads per day. And in this 90 uploads, you can only send 8 bits. I think it's 8, if not 12. It's been a while since I used Sigfox, but it's somewhere between 8 bits and 12 bits. And you can only do that 90 times in a day. So I remember I had a project that was using Sigfox technology, and we are using sensor data from the Arduino, and then we uploaded it to the Sigfox backend, and then from the Sigfox backend, you can channel it to any other cloud solution, for example, Azure. Yeah, so they are mostly used for wide-scale deployment of field sensors, like Liquid Technology the other day launched a project. I think it was last year. They are working with fish ponds in Kisumu, and they were able to identify where they are and actually communicate with their cloud information to get information about fishes and everything. So I think that's enough about Sigfox. On to the last item, which is LoRa technology. LoRa also is quite similar to Sigfox. It's also low power, wide area network, just like Sigfox. And apart from the main thing that is normally best about LoRa is the fact that it has so many companies which are subscribed to their services. Like they are making devices that are actually LoRa compliant. So you will not have to go out of your way so much for you to be able to access their services. They work actually the same with Sigfox and the other what's it called? Okay, like okay, Sigfox and LoRa, they are the same. There's no better way to differentiate them other than the fact that they work on the they work, one is proprietary and the other one is a bit open source, because for the Sigfox one you have to get the specific Sigfox compliant boards, but for the LoRa there are so many boards out there that you can just add a simple functionality on top of it and make it LoRa enabled. So these are the best methods you can use, and what I can advise one to use is the MQTT one. It's very simple, it's widely documented, and it's very easy for you to actually achieve something big with it without using a big budget. So I think this will bring me to the end of the presentation. And if you have any questions, I can see the time is up. So I'm just going to have to give control over back to Julia. Julia, are you there? Julia? Hello?
Yes, hello.
Yes, hello.
So
Hello.
let's have Dominic. Dominic guide us on the next speaker.
Nice, Mwasela.
Okay, hello. We have done
Dominic, we can't hear you quite well.
I said our next speaker will be from DRC. His name is Gratians.
Okay, thank you.
Yeah. Are you on the line?
Hello, everybody. I'm Guza.
Yeah.
I'm from DRC. Today, I will not be here to talk about sensors or other, but I will give you the impact of Internet of Things in financial industries. Let me share my screen. I have something to advantage of IoT in financial and downside. I will thank you for your attention. I give you a big rate. I don't find my PowerPoint because I'm using my phone now, but I can tell without this PowerPoint. Internet of Things is the one the hottest topics today that penetrate all spheres of life, from healthcare to commerce, for example.
Sorry, I can't quite hear you.
Hello? For example, of Internet
Your
of
tone is
Things,
breaking.
I can give you the example of Coca-Cola as an industrial was automating machine that can, for example, report how much stock they had and where the drink were ordered early in the 20th century. Internet of Things is a technology that we know has got a lot of sensor, for example. We talk about Internet of Things in embedded system, for example, but we usually don't talk about the financial industry in all what we can talk about. We forget that this concept can be applied in all technologies where data are sharing with internet. We should notice that Internet of Things can be applied in the financial industry. For example, I can give you the example where bank starts. When bank starts, bankers and always use for example, paper to write transaction. People wasn't able to know how many money they got in accounts, for example. But with the Internet of Things, bank can share data like the among all of the customer. This data shown online. This data can be saved, and it isn't the only one aspect of Internet of Financial administration, for example. We can also talk about, I know that there is a lot of person who can't know what is trading, but I can make a little presentation of trading. Trading is a way where brokers can take your money and put it in Wall Street, for example. Any trading in the past, traders used graphics to predict the movements of the course of money, for example. But with Internet of Things, all changes. Internet of Things provide to traders a lot of tools to manage his money. For example, a trader can take can receive notification about the cost of USD euro, for example, or Japanese yen, France CFA, for example, or euro. In the advantage and downside of Internet of Things finance, we can notice that we got
hello Dan. Hello Dan. Hello Dan, can you hear me? Hello Dan, we can't hear you well. There's some issues with your internet connection, so kindly just allow us to dive into the Q&A because of time. Time is really much gone. So maybe Dom can just briefly take us through the Q&A, and then we will have another session. We will organize for another session, and we will just continue from where we've stopped. So kindly just allow us to do that because of time. So Kata, kindly just take us through briefly the Q&A session.
Hello, Dan, we are really sorry to cut you short. So actually we're running out of time. So we'll just open the session for a few questions and then we break. So anyone here who has a question to the guest or to anyone in the platform? Guys, this session is open to anyone who has a question. Kindly ask. So it seems like there's no question. So Steve, are you on the line?
Yes, I am.
Yes. So maybe we can just end the session, then everyone to break. Or what do you think?
Yes, because none of the participants seems to have a question. Let me just
sure.
check. Let me just check on the chat. Somebody else. Okay, it was Julia. We can end the session, Kata. Thank you, everyone.
Okay, so thank everyone who attended this session. We'll have more sessions on IoT channels and on other MSP general meetings channel. We plan to have more guests, more so from the Microsoft community. We also plan to have some demos and more great stuff will be coming your way. So thank you for staying in touch with the Microsoft student partner community, and we'll be seeing you in our channels. Thank you. Bye.